In this section, we're taking a look at solving equations. So when we're working with solving equations, it's important to remember we're using opposite operations. We're using BEDMAS in reverse to solve for a missing variable. And we can only solve for one missing variable at any given time. We can't solve two variables at the same time. Recall BEDMAS, brackets, exponents, division, and multiplication in the order they appear. So you can do multiplication before division. It's in the order these two appear. Same with addition and subtraction. They're the last two, but they happen in the order they appear. In our case, we're going to be doing this all in reverse. Working with addition and subtraction first, with division and multiplication, then exponents, then brackets. We have a reminder of opposite operations. Plus and minus are opposite operations. Times and divide are opposite operations. Squared and square root would be opposite operations. Couple tips to remember, help you out with solving these. Expand brackets and collect like terms whenever possible. At any given step, if you can collect the like terms and expand brackets, do so. It'll make your work easier. Avoid using the divide and time signs. We want to use our brackets or mathematical dots for multiplication. We want to use our fraction bar for division. So we'd have something like this, x plus 3 over 4, rather than x plus 3 divided by 4. Okay, we don't want this. Don't use that. Bad. We want the division bar. Okay, so makes it look like a fraction. When you're working, always move all your variables to one side. That will make things, again, easier as you're solving things. Do that first as you can. And then the last one is more for the dependency on your handwriting. If you have really sloppy handwriting and some of your letters start to look like symbols, your 5s look like S's, your T's look like pluses, things like that, then you can change the variable to something that won't become confusing. Some students have messy handwriting and their T's end up looking like pluses. If that's the case, then what you can do here is just change the T to say a W. So we could then work with that, and then as long as you get to the end where you have to have maybe say W equals 6 or something as an answer, then you just change the W to a T. That's it, and you would have in a little more clear, especially as you're working through a question, if you get distracted for a second and come back to it. Oh, was that, if this was, say, 3t plus 4, oh wait, is that 3t plus, 3 plus positive 4? So you don't get confused. Sometimes that's useful. Or make sure you really differentiate your letters. I usually try and draw a T like that because it looks different. Just like my X's, when I'm using them as variables, I kind of make like two C's, one forward, one backwards. My S's, though, are really bad. My S's tend to look like my 5s in many cases, so I try and avoid that when I can. Solving one-step equations. So we're going to start just one step. One thing's got to happen. We got to do one opposite operation. A lot of these you can probably do in your head, and that is wonderful. Love mental math. However, there is a process that will make a lot of your work easier, and if you can follow the process and write this out exactly the same format that I do, you will find that this algebra will become infinitely easier for you. Things to keep in mind, when I do this, I usually start by writing my equal sign because I want to keep my equal signs lined up. And then what I'm doing here is I got to get the x by itself, so the opposite would be to get rid of the 3. Okay, so I'm getting rid of a positive 3. This is like a plus 3. I'm going to get rid of that by subtracting it from both sides. So I would have 3 plus x minus 3. I've added a minus 3 to this side. And then whatever I do to one side, I have to do to the other. So I have to add a minus 3 to the other side. You got to keep the equation balanced to keep it equal. Whatever you do to one side, you need to do to the other. I'm just left with an x here. And on the other side, I'm going to be left with a 4. X equals 4. 3 plus 4 is 7. That checks out. So you can always take your answer, plug it into the equation. Both sides should end up being equal. The next one, I have 3 minus x equals 7. So in this case here, again, I have a plus 3. I got to get rid of that by subtracting it from both sides. So I have 3 minus x minus 3 equals 7 minus 3. I'm left with negative x. Notice I brought down that negative sign with the x. This whole thing, it stays. You can't just make the negative sign go away. Especially in a question like this, which leaves us in an uncomfortable spot because it's negative x equals 4. A lot of people don't like that. They're like, well, it just must be 4. It's not. If negative x is 4, positive x must be negative 4. Okay, we just switch both to their opposites. That's an easy way of doing it. In the next case, I have x minus 3 equals 7. Here I'm subtracting 3. If I'm subtracting 3, the opposite would be to add 3 to both sides. So x minus 3 plus 3 equals 7 plus 3. I'm left with x on the left side. I'm left with 10 on the other side. X equals 10. 10 minus 3 is 7. That one checks out. So that's some adding, subtracting work. Now we got some multiplication and division. In the next case here, I got 6 times x equals 24. How do I get rid of times 6? I divide both sides by 6. So I take this side, divide it by 6. Take this side, divide it by 6. Notice I'm using the division bar. Don't use your divide sign. Use your division bar. These 6's end up canceling. I'm left with x here. 24 divided by 6, going to give me 4. 6 times 4 is 24. That answer checks out. In the next case, I have negative 7x equals 49. I'm going to divide both sides by negative 7. We're changing the operation from multiplication to division. We are not changing the sign from negative to positive. We're changing the operation only. I divide both sides by negative 7. So I get left with an x on this side. On the other side, I'm left with negative 7 as my final answer. Negative 7 times negative 7, that's equal to 49. This answer checks out. In the last one, I have x divided by 4. The opposite of divide by 4 is to multiply by 4. So I'm going to multiply both sides by 4. The 4's here will cancel on this side, leaving me with x. And then 12 times 4 is going to give me 48. So there's some one-step equations. One thing to undo in each case. Whatever the opposite operation is to get the x or variable by itself. If I flip the page here, continue with some solving two-step equations. So in two-step equations, there's going to be 2 operations we got to get rid of. Sometimes these can get confusing as to what we need to do. So sometimes I look at it like this. If I was calculating this equation, I would first start with the x. Always start with your variable. Then 2, I would multiply it by 4. Following BEDMAS, normally I would multiply by 4, and then I would take whatever result I got from 4 times x, and I would subtract 7. And finally, I would get 10. That's the series of steps that would do this equation. It would, BEDMAS would say multiply, then subtract, and get the 10. I want to undo all of this to get the x. So I want to do everything in reverse. Thus, my steps I want are to start with 10. We're going to add 7. The opposite of subtract 7 would be to add 7. Then I would divide by 4. And finally, that would get x. Okay, so this is what is called the do-undo method. Do not make this your primary method of solving these. It's just a way to help you get your head around the order that you would perform the calculations. This is normally what you would do. You do multiplication, subtraction to get the 10. Here we have to undo it by doing everything in reverse. Thus, reverse BEDMAS says we'd start with that subtraction and get rid of it. 4x minus 7 plus 7 equals 10 plus 7. We're going to add the 7 to both sides. We're left with 4x equals 17. And then we need to divide by 4 on both sides. And this will get us our x. So x equals 17 divided by 4, which is perfectly fine. I like fractions, so you can leave 17 over 4. Or if you are still fearful of fractions, you could get 4.25 as a decimal. So both of those are acceptable answers in that case. A couple more examples. So here we would initially multiply x by 3, then subtract the 6 to get the 12. So let's do everything in reverse. We're going to get rid of the minus 6 first. Negative 6 plus 3x plus 6. That'll get rid of it. And then we add 6 to the other side as well. So we're left with 3x equals 18. And just divide both sides by 3. And we're left with x equals 6. And again, you can check that answer. 6 times 3 is 18. 18 plus negative 6 is going to give us 12. So that one checks out. Now, if you're comfortable and you don't want to do the extra writing, I generally don't in my practice do the extra add subtract portion. I'm going to show you a slightly modified way of writing these equations. It's still the same process, just written a little smaller and neater. So in the first step here, I would need to subtract 2 from add 2 to both sides. So what I would do is I'm going to end up with 7x, because I'm going to get rid of that negative 2. And then on the other side, it's just going to be 8 plus 2. So I skip writing that extra portion like I did here, is all I'm doing. I'm just skipping right down to the next step. So I have 7x equals 10. And then I'm dividing by 7 on both sides, so I know that my final result will just be x on this side, and then I'm going to be dividing by 7. So I just don't write the extra portion over here. It's a little shorter, a little neater. So 10 over 7, perfectly fine answer. If you want to get a fractional type answer or a decimal type answer, you can do 10 divided by 7 and get a different, or get a decimal. This would look the same. Okay, this is the same as if I did this the longer way and wrote everything out. So if I had done this writing everything, it would just look like this. 7x equals 10, and then divide by 7 in both cases, and I'm left with x equals 10 over 7. It's the same answer. I'm just making it a little simpler, not putting this portion and this portion in. It's just a little cleaner. I prefer this method, but if this gets you confused, you're welcome to continue using this regular method here and showing what you're taking away on both sides until you're perfectly comfortable with simplifying things. Now moving on, we got multi-step equations. So here is where we might have brackets, we might have exponents on both sides, we might have more than 2 calculations to do to move through everything. In the first case here, we have 7 minus 2x equals 8 minus 5x. We want to get our variables on the same side first. That's going to be my first goal. And then we want to get the constant numbers, 7 and 8 on the other side by themselves. I'm going to do 2 steps in one. I'm going to move the negative 5 over to this side, and then I'm going to move the 7 over to this side, all at the same time. So I'm just doing 2 steps at once. It allows us to write our equations a little shorter. So this would end up being negative 2x. This will be plus 5x on that side. and then this would be 8, and then on the 7 would move over and become minus 7. This ends up giving us 3x equals 1, and then we divide both sides by 3, and we're left with x equals 1/3. If you wanted to write this out the longer way, 7 minus 2x minus 7 plus 5x. So I'm getting rid of the 7 and I'm adding the 5x to that side. On the other side, it would be 8 minus 5x minus 7 to move the 7 over, and then plus 5x. And you're still left with the 8 minus 7, which is 1. You're left with the negative 2 plus 5, which is 3x. And then it would divide both sides by 3. Again, you can see this is a little bit neater in terms of visually seeing it. So we're just skipping what becomes essentially an extraneous step. A little less writing, a little less chance for mistake. In this next one here, we have some multiplication with the brackets. So we got to deal with these brackets. So we're going to get rid of the brackets first. We have this first one we need to expand with the 5. So we're left with 5x minus 15. In the next bracket, we have a negative in front, so both the signs switch. Or you could say this is a negative 1, and we're going to multiply both by negative 1, which again gets us negative x and positive 2. Both the signs switch. That equals 19. Now I collect my like terms. I got like terms on this side, so I'm going to collect those. I have 5x and negative x. That's going to leave me with 4x. And then I got negative 15 plus 2. That's going to leave me with negative 13, equal to 19. Now I have just a two-step equation left. So I'm going to get rid of the 13. 4x equals 19 plus 13. 4x equals 29, 32. And then divide both sides by 4. I'm going to get myself an answer of 8. And we've done multi-step equations. So multi-step equations just involve one and two-step equations as you work your way through. May have some collecting like terms, may have some expanding the brackets. The last part I want to look at, I know this is a longer one, but we want to go through all our different equation types. We're going to look at solving equations with some fractions in them. So in the first case here, we got 6 equals 1/3 times 8 plus x. I can get rid of this fraction by either expanding, or it is 1/3. I could just multiply by 3 to get rid of it. If I multiply a third by 3, it becomes 1, and it will be negated. So I'm going to multiply both sides by 3. 6 times 3 equals 1/3 times 8 plus x times 3. So this 3 and this 3 would cancel. This would become 18 equals 8 plus x. And now I can just move that positive 8 to the other side. 18 minus 8 equals x. And I'm left with 10 equals x. So I can multiply, if it's 1/3, I can just multiply by that to get rid of it nice and easy. In the next case, the 4 is dividing the entire side. So the 3x minus 5 is divided by the 4. So we can get rid of that 4 by multiplying by 4 again on both sides. 3y minus 5 over 4 times 4 equals 7 times 4. These 4's cancel. I got 3, and I'm actually going to expand this in the same step while I'm here. 3 times y, and 3 times negative 5, and then 7 times 4. So I've gotten rid of those 4's, and I've expanded that all in the same step, just for convenience. And now I'm going to solve this. I got 3y equals 28 plus 15. It's going to give me 43. And now I just divide both sides by 3. 43 over 3. Again, fraction is perfectly fine. If you want a decimal, 43 divided by 3, you can do that. I don't recommend doing mixed numbers and things like that. In most cases, a fraction or a decimal will be most apt. So one more. In the last one here, we have a division on both sides. So this one here, because we're dividing on both sides, I can multiply by 4 and multiply by 5 to get rid of them. So here we're really looking at, if you recall, a cross multiplication. We can cross multiply here. We'd have 5 times x plus 2 equals 4 times x minus 4. We've multiplied this side by 4, it gets rid of it, gets rid of the 4. So multiply this side by 5, gets rid of it. And so we also have the 4 and 5 now left on either side. We're left with 5x plus 10 equals 4x minus 16. I'm going to get the x's over to one side, numbers over to the other. So this is going to be a subtract 4, 5x minus 4 on that side. Move the 10 over, negative 16 minus 10 on that side. We're left with x equals negative 26 as a result. So there you have it, solving a wide variety of equations, one step, two step, multi-step, and solving equations with fractions.